Hey guys, this is Aryan Singh, and today I'll be demonstrating Apache Kafka in its multi-partitioned and clustered mode. As we know that Apache Kafka has an inherent ability of seamless switching between brokers. If one of the broker goes down, it automatically switches to the second broker. So this comes from the fact that each topic in Kafka can be multi-partitioned and replicated. So if I have a topic in Kafka which has multiple partitions, so and I mention a replication in it, so each partition would be maintained in multiple servers. And out of these multiple servers, one would attain the leader role and other would be a slave. So once the leader is executing the tasks or keeping the data for that partition, it is fine. But if the leader goes down somehow, the slave or the follower, it will take over and it will become the leader and continue the task. So it will not hamper our broadcast to the queue and fetching from the queue. And this happens seamlessly and is internally managed by Kafka. So I'll be demonstrating that along with a few other things. So this is a tool called Kafka Tool 1.0. It's a beta version, and it is basically a GUI into what all we can do in means what I am doing in Kafka. So if I see here, I have two brokers of Kafka running in my machine right now. Okay, one is running on 9092 port number, and the second one is running on 9093 port number. This is two instances of Kafka. So for this demo, I have created a topic that is test notif. If I see, it has two partitions, so it is a multi-partition topic and a replication factor of 2 for each partition. So each partition will have a copy running on another server. So if I see this partition, it has the main partition running on 9092 and a replica on 9093 running correspondingly, and similarly goes for partition 1. And if I see here, for the first partition the leader is 9092, or the 0 partition the leader is 9092. Oh sorry, I think I'll need to reconnect this. Okay, so now we can see that for first partition the leader is 9092 and the second partition the leader is 9093. So we'll see the seamless switching of the leaders once we start our demo. So basically this is the setup I'm going to work with. So now let me show you that this is my first Kafka instance, and that is being run on 9093 server port number, and this is my second instance that is running on 9092 port number. Now let me go to Eclipse and show you my code. So I have two separate projects, simple Java Maven project, sorry, and one is a producer and other is consumer. So my consumer, if you can see, I'll be just showing you in a minute. Yes, if you can see, I have two consumers, one for each partition as is recommended. So both will be polling my Kafka broker, and as and when the producer will keep the records there, it will pull out the records and keep on dumping them wherever I want. And for this purpose I am using a custom encoder while producing, and then decoder. It is encoding this into a JSON from my bean and then decoding at the other end. This is a custom bean I am sending, so I do not have to do any encoding or decoding of JSON into beans. It is handled automatically by Kafka. So let's start the demo. First of all, I will start my consumer group so that it is ready to go and fetch the records from the broker when the producer will produce the records. So let's run this. So here you can see I've started my consumer group. Now I'll start to produce the records, or start to keep the records on the queue. Here you can see I am producing 1 million records on the topic notif tester that I created earlier. Here you can see that test notif, sorry. So let me start this off, and we'll start to see the records appear in the console as and when they appear. So now see, both my consumer have started fetching the records. I'm printing this timestamp along with it. Now let's see what Kafka tool displays here. I'll just refresh this connection so that you can see the fresh things. So I can see here that the leader configuration is 9092 for 0 and 9093 for 1. I can see both my partitions. I can see the data is getting populated continuously. So if I do my limit here 10,000 and I do this, I can see the data is coming continuously. It is getting populated continuously, and same goes for partition 1. Now let me just go and shut down one of the brokers quickly. So I'll shut down one of the brokers. So it is shutting it down. Now you can see that even when the broker is shut down, my fetching operation is going seamlessly because the control of the partition is being seamlessly shifted to the second broker. So this broker has been shut down completely now. Now if I refresh this, I will see that 9092 has assumed the role of leader for both the partitions, and I can just reconnect, and I will just see that the data for both the partitions is seamlessly transferred over here, and you can see there was no lag or anything when one of my brokers shut down, and Kafka internally made 9092 leader for both the partitions, as it had a replica of partition 2 also. So it seamlessly took over and it is transferring the data. So this inherent ability of Kafka to automatically handle failover and transfer to the other broker is really great, and it saves us a lot of time. So now you can also see that there is only one broker running. 9093 has been shut down, and also I can see my consumers over here if I want. So I can see here my fetching has been completed, and it took me around about 3 minutes to transfer 1 million records of 1 KB each over Kafka, even when I shut down one of the brokers. So this is the failover handling capability of Kafka in multi-partition and replicated topics. So I think I have pretty much cleared out everything and every doubt regarding this. Thank you.